All right, so in our last video, we talked about letting n get bigger and bigger so that we get better and better estimates, but we didn't actually answer this question of approximating the area between the curve y equals x squared and the x-axis from 0 to 1, dividing into n subintervals. So let's think about what happens as we're finding our total area and creating more and more subintervals. Well, the higher that n gets, the closer that my delta x, remember delta x was going to be 0 to 1, so that distance, so 1 divided by n. So as I'm letting that n get bigger and bigger, this delta x, the width of my rectangle, is getting closer and closer to 0. So really what we're looking at is our total area is going to be found as our limit as dx, or our delta x, goes to 0 of our sum of our function value times dx. Well, and we're evaluating this for our function values between 0 and 1. So we're taking all of those values, summing them up, and in the end, this sum, when we have our delta x approach 0, this is like when we were looking earlier. Sorry, you can see that I'm thinking ahead. This is our delta x. Well, what we saw thinking about the slope and the derivative is that as I let my delta x go to 0, that becomes my dx. So we can rewrite this area as the integral, it's a stretched out s sign, between my two values. So this really means from x equals 0 to x equals 1 of our function with regards to x. So as delta x goes to 0, I'm taking my integral, putting in the values means I am finding a definite integral. So I'm going to take my integral of x squared, because that's the function we're looking at here. So we've got the integral from 0 to 1 of x squared dx. I know that that's going to be 1/3 x cubed. Now instead of plus c, what I'm going to do is I'm going to evaluate from 0 to 1. So I'm going to take my largest number and plug it in, and subtract the smaller value. So I get that my area is about 1/3. If we look at our values here, and we should have actually calculated them so that we could compare, we would see that we're getting closer and closer to 1/3.